In order to do that, we need to know something about the geometry in this system. So, important elements of geometry, well, obviously the angles that these lines are at matter, because if they're pulling straight up and down, then Pat's going to have to pull quite hard. So let's call this theta 1, and that's theta 2. Now, what do we know about theta 1 and theta 2? Well, if Pat's pulling straight down, then this pulley is going to move so that theta 1 and theta 2 are equal. Right? If it was way over to the side here, Pat would either have to pull this way to keep it over to the side, or Pat would have to move over towards the middle so that theta 1 and theta 2 were the same. Likewise, if Pat was over this way, Pat would have to pull this way or move towards the center. So if Pat's going to pull straight down, theta 1 is equal to theta 2. Or let's say approximately equal to theta 2. And they're both equal to theta. So it's pretty close. Now the other thing that's going to be important that tells us how hard Pat is going to have to pull, this force applied by Pat downwards on the rope, is going to be what the tension is in the line. Now the tension in the line, how hard the line is being pulled or stretched, it might not be the same in every location. This section might have tension T1, that one T2, and this one T3. And they might be different. In fact, if the pail is going to go up, then T2 has to be bigger than T3 to overcome the friction in this pulley. And in order for the line to roll through this pulley, as Pat's pulling down, because there's going to be more line over here the further Pat pulls down, so the line is moving that way through the pulley, T1 has to be bigger than T2 to pull it through the pulley and overcome the friction in this pulley.